Hello and welcome to the ADS and VSAE webinar on blockchain. We're very excited to have Julian, Wraith and Éva Kalmár here today. So I just wanted to give you a little introduction to Amsterdam Data Science. Amsterdam Data Science is a network organization that connects academia, industry and society in the fields of AI and data science, specifically in the Amsterdam region. And we do this through our webinars, and pre-corona we also did physical events, and hopefully we'll get back to those at some point. But for now we are doing this A to Z in data science series with the study associations associated with the University of Amsterdam and 𝗕𝗹liche Amsterdam. And this is to give a really nice introduction to different aspects of data science and how they can be applied in industry. So today we are partnering with the VSAE, and they are from the Study Association for Econometrics at University of Amsterdam, and I'll let Koen give you a little bit more information on them.
Yeah, hi. So hi everyone. I'm part of the VSAE, which is a study association for econometrics students at the University of Amsterdam. I guess it's all in Dutch, so I'll have to translate some. But it's mostly econometric students. Basically, 3 out of 1 is 3 econometric students, then 1 actuarial science student. Mostly men as well, 2/3 are men, and 20% is international as well. And basically what the study association does is we do social activities, which of course are very limited right now. But apart from that, we also have career orientation events, and we have like broadening your knowledge type of events, such as this webinar. So I'm looking forward to get to know more about blockchain.
And yes, I'd like to introduce Julian Wraith, who is the Principal Solutions Architect at Amazon Web Services. And Julian works across many areas, including blockchain, machine learning and AI, and data analytics. And today he will be talking about which cases are most suitable for blockchain and ledger applications, and which might be better off with a different type of database. We will also be hearing from Éva Kalmár, and she is a science communication lecturer and researcher in communication design for the innovation group at TU Delft. And Éva is investigating collaborations between scientists, business partners, and governments in the context of technology development and scientific innovations. One of these investigated innovations is blockchain, and so she will be talking about the current trends in blockchain research. But yes, without further ado, I'd like to hand over to Julian.
So, hopefully you can all see my screen. Thanks for the opportunity to present today. To you guys. It's really good to be here to talk a little bit more about both blockchain, also a little bit about what AWS does, and the types of things that we can offer in this space. I'm Julian Wraith. I'm Principal Solutions Architect for AWS. I have been so for 4.5 years, and I have main focus on areas like retail, healthcare and life sciences, IoT, also blockchain, machine learning, these kind of technologies and how they support those industries. Today, we're going to have a look a little bit at what are technical use cases that would be most suitable for blockchain and ledger services, and which may be better off with a much more straightforward database. I'm going to talk a little bit through some customer stories and how they used blockchain and ledger technology for their use cases and why they chose those. A little bit about AWS, if my slide will turn. There we go, perfect. So who is AWS? Everybody knows Amazon. Amazon Web Services is a part of that organization, and we are essentially an organization of builders and innovators. We like to deliver capabilities towards our customers, and as such we have 175 services that you can use yourselves to build applications to solve a myriad, almost unlimited range of business problems. We also have a wide range of technology partners, who also supply different software and technology built over our services, which will further enhance the options and choices that you have available to you. We believe that availability of different services is an important part of customer choice, because it gives you the opportunity to choose the right technology for the job, not have to make compromises in what you would like, but also the ability to choose something that is really just suitable for that particular job. And that's a little bit what I want to talk about today. So I'm going to walk through some small little scenarios, little use cases, fictitious use case, but hopefully it resonates a little bit with the audience, and see how different requirements on those use cases change what we're going to actually use to implement it. So I've made a fictitious example here. We're going to keep some accurate records about our research. Now, what could those be? Perhaps profiles of participants in a study, with a list of medicines administered, maybe some metrics about their blood pressure, these kind of things. We want to keep those records over time, and we maybe want to also keep some information about who has accessed that data, who has downloaded that data as part of working on the research. So do we need to use a blockchain network to solve this problem? Largely, no. Widely adopted technologies can be used to track and record data. A blockchain network per se does not necessarily increase the accuracy of the recorded data. It's obviously up to applications submitting data into the storage to deliver good data. So bad data in also means bad data out. And the applications you build around the technology should be validating and making sure the data is correct. How we would normally solve this is that we'd use standard common databases to provide the data store. We provide managed services with a service called AWS RDS, a relational database service, which take the heavy lift out of managing that database. Instead, you can kind of focus on the individual capabilities of the database, such as storing, inserting, deleting records and rows in an accurate way. You can also use, for example, S3, which is a flat file storage, in essence, block storage, where object storage, sorry, where you could record log data, for example, which you can then use in dashboarding and analytics to show who's had access to the data. So that's the kind of first level of data storage for storing information about our research. However, if we put in a requirement that our records must be auditable, that changes aspects of this. But does it really then also require a blockchain network? Well, blockchain does provide some capabilities here, but we'd also say no. So in AWS, we have a technology called the Quantum Ledger Database, QLDB, and QLDB offers an immutable single source of truth, where the records in the database are cryptographically verifiable. In essence, then each record contributes to a hash of itself, and that hash is then added to the subsequent record in the database. That means that any modification of that data anywhere would result in a different hash and every hash following that. So we're able to go back and look at the data and say, okay, is this data 100% how we put it in? QLDB itself doesn't have any APIs, in fact, to really sort of delete data or update data. It's an append-only database. You can add updates to the data, and that is it. It is also possible in QLDB to go back and have a look at the state of the records at any one single point in time. So if you have to prove how something was on a particular day, it's possible to do. So why, what is it going to deliver you and why is it helpful? So of course, immutability and verification of records is going to reduce risk. If we can't delete records, then we will prevent the risk or reduce the risk of any data loss of our data. We're able to prove the lineage of the data if we can go back and have a look at exactly how the data looks on a particular day. And in, for example, examples where you're manufacturing a product, you may be able to go back and have a look at where a particular product was sourced from, where it was manufactured, which production line, which day, which might help you reduce issues further down the line with other products by having that lineage of data that has never changed. In auditability sense, because we can prove that the data is unchanged, because the data is only append only, we're able to save a lot of time in reducing the time needed to prove compliancy. And 𝗕𝗹CE is providing this capabilities out that is a correct way of doing that. This is an out-of-the-box capability. Highly scalable application. So as opposed to blockchain, 𝗕𝗹CE doesn't require a large-scale consensus to complete a transaction. So committing transactions to the database are very quick. And it's built over AWS technology. So we have the ability to scale up and scale down as the workloads increase. And 𝗕𝗹CE uses an SQL-like interface. So if you're familiar with SQL and you're familiar with working with MySQL databases, learning how to use 𝗕𝗹CE is a very, very straightforward process. Okay, so what if we, again, add some requirements, and now we have multiple organizations, but multiple organizations are trusting our organization to be the central authority of the database. So again, should we use a blockchain to do this? And again, a little bit no. At AWS, we add additional technologies to enable you to make a data store such as 𝗕𝗹CE available via API or web interfaces, so that external parties can append data to our record sets. As central authority, we can validate all those transactions. We could do that in a way that's agreed with all parties, but it's really up to us how to do that on the database in the right way. Slight downside of this is that we get all the work of supporting these applications, supporting the interfaces, and maybe that might make a difference to the budgets and things that we have for our projects if we're going to be the central authority. That's a bit of a downside of such a setup. But what if we wanted to have multiple organizations distributing the responsibility of being the authority? Should we use blockchain? Well, yeah, now there's a more suitable use case for using blockchain. In a public network like Bitcoin that we're probably relatively familiar with, you don't trust other parties. However, in private networks with a finite number of participants, we trust other parties to be good citizens and take responsibility for the work of validating the data, voting members in and out, reaching consensus on what constitutes a valid transaction. And because there's no central authority, everybody's sharing this work and everybody has a copy of the data. And it is not required that the central authority, there is no central authority, remains in the network at the whole time. Because of that copy of the data, they don't need to ask any other party for the access to the data. They have a copy of the data. They can independently audit and verify that data in the network. Consensus of transactions. So when we want to be sure, when we want to have consensus between all the parties that a transaction being written to the blockchain is a valid one. In a private network, we can use different mechanisms to do that than maybe a public network, where we can, for example, use things like lottery-based algorithms to select a particular member in the network to do the validation of the transactions, rather than maybe more expensive public-style consensus, which take a lot more participants in order to prove the transaction as being correct. So Amazon Managed Blockchain is a fully managed service on AWS. So we take, again, away all the heavy lift of managing the infrastructure, but you only need to manage building your application over the top. And we support both Hyperledger Fabric and Ethereum to give our customers the choice about how they how they implement their network. Hyperledger Fabric is good for maintaining private networks with a small number of permission members, whereas Ethereum is better for public networks or large-scale private networks with a large number of with members. And managed blockchain is from Amazon is easy to scale because it's built on top of our infrastructure, and it leverages key functionality that is also very scalable, such as things like the key management service storing users' network certificates. What Amazon did with this service as well is that we used other services from AWS to improve the reliability of certain capabilities within most networks. So for example, in a Hyperledger Fabric ordering service, it's actually underpinned by QLDB. So you get the same technology and the same immutability and reliability that you get with QLDB, and that's built into our managed blockchain service. So an example of an organization that does this, Nestlé, uses Amazon Managed Blockchain to track the provenance of coffee through their supply chain. So from production of the raw material right through to the production of the final product, they can trace that source of the coffee that you're drinking back to, in some cases, the exact location on the farm where the product was grown, but it's certainly up to the supply level. The implementation of this allows different partners on the chain to verify each other's transactions. And because it's immutable, nobody can modify the data once it's verified. Nobody can change things like the quantity or the quality of the coffee that's going through the supply chain. And because of this, Nestlé is able to have a higher level of accountability in the supply chain. And ultimately, that's about then delivering a better product towards their end customers, better coffee. An example of a customer who uses QLDB is a DVLA. A DVLA is the UK Driver and Vehicle Licensing Agency, and they are the central authority for vehicular-related registrations, and they have a very, very high number of records stored in their environment. And there's a very, very high demand for this data. So they have things like clean air zone enforcement, parking permits, these kind of things. People need to have access to this data to ensure that they can implement secondary capabilities or secondary functions around car driving and car use. The data sets are also growing in both the volume, but also the types of data, such as data from connected vehicles that is added to this environment. And data provenance for this data is extremely important because they need to be able to demonstrate what the state of the data was at any time, because they're asked to provide legal enforcement and prosecution data. For example, if was this person a license to drive on this particular day at this particular time. DVLA chose QLDB because it offers this append-only approach, so their auditability standards could be very high, and they're able to easily provide that current state and history of a particular record or a particular vehicle. AWS, as I mentioned, has 175 services, and this is just a very, very small snippet. We have all sorts of services from compute, database, storage, analytics, etc. On the right, you see blockchain. In the middle are our databases where QLDB sits. And then based upon the data that you might be gathering as far as records, we have analytics services to provide additional analytics capabilities over the data. And we obviously would like to have business intelligence, so we have to dashboard that data and also run AI/ML based activities over that data. And all of that is underpinned by near infinite storage from S3 with services like lake formation for building data lakes, glue for running transformation on the data. And of course, getting data in and out of AWS, being able to transport large volumes of data, things like Snowball, Snowmobile, and then things like streaming services. And I'll leave you a little bit with some additional links, which you can find online to learn a little bit more about the types of services, specifically the first one, which is an open source list of research-based resources, trainings, and information from AWS that will help you with research activities.
I guess we can start the Q&A now. There are a couple of questions. Let's start from the top. The first question is by 𝗕𝗹cije𝗰𝗵𝗶𝗰𝗵, and he asks whether is QLDB based on Hyperledger or AWS custom technology?
That's a great question. It's based on AWS custom technology. So many of the services that we share with our customers have originally been built for another purpose, and in this case, QLDB is part of what makes up our internal compute services, and this is let's say a public version of that environment for you to use.
All right. Then another question is from 𝗕𝗵ecie𝗰𝗵𝗶𝗰𝗵𝗶. He asks, what if the majority of organizations is connected as a cartel? That would change the overall authority in a way that's fraudulent, right?
Yeah, so this comes down to how your consensus mechanism works and your level of trust of particular organizations. So in like a Hyperledger Fabric private network, you typically have some level of trust of the other parties. So if you're doing research with maybe multiple universities, you assume maybe on a paper-based agreement, or because you share the same goal, that you're not going to be entering fraudulent activities. That could of course not be true, but you know that's most likely to be the case. On a public network, you typically don't know the other parties, and so in that case, you need to do different consensus mechanisms in order to make sure that the transactions are valid. In the case of Bitcoin, they use the mechanism proof of work, where we all heard Bitcoin mining. There has to be a consensus of the majority of all the members to be able to commit a transaction to the network. And the theory is, by having the majority will not be fraudulent. It's not possible for one party to take over, a cartel to take over. Technically, it is possible, I think.
All right. Then from Hans, he questions, how does AWS guarantee the immutability?
That's a very, very good question. Through the application design, in that sense, as I mentioned to you before, there is no possible way from an API or use of the product to delete the data or to modify the existing data. As a service, you have no access to the raw database files, like you might have, as we say, if you use a SQL Server database, you have access to the rows in the data. You do not have that level of access. There is a technicality in immutability for QLDB. If you delete your use of the service, you delete your data, of course, but provided you always run the data, you have no opportunity to change the existing records. And yeah, that's part of the service we deliver towards our customers. Hopefully that answered the question.
Yeah, and if not, I guess they can always post the question again.
Have an additional I'll be on chat.
All right. Then let me see. Oh yeah, we got some time. Tomislav, he asks, in the Nestlé case, did the introduction of the technology have any impact in the way coffee production itself was organized?
That I don't know specifically. I wasn't unfortunately involved in the project. I think the best way to adopt such technology is to fit it into the types of production techniques that are used, and to make these things accessible easily with the participants that are going to be working with us. So, for example, in the case of farmers, you need to implement it in such a way, maybe with for example, a smartphone app, that kind of thing, where they can easily, with a low threshold, enter this kind of data to participate in the network. That'll depend upon the region of the world, but such technology is relatively widely adopted. You kind of need to make it easily accessible and fit into that process. Indeed, if you change completely the way people do things, it's not going to help make it successful.
All right, then before I move on to 𝗕𝗹cie, to two other questions, there was Hans who thought it was not a satisfying answer on immutability. So he asked, maybe better formulated, an AWS interfere with the QLDB database, have row level access, etc. Is it clear for you what the question is? Yeah, maybe Hans could rewrite it a bit.
I will, I'll ask you a second question. I'll have a look at that one in a moment when I can type an answer to Hans.
Yeah, sure. Let me see now. So 2 questions. Let's start with the shorter one. A solution on huge research data sets outside blockchain could be using a unique fingerprint style model where only fingerprints are stored in blockchain. Any ideas/comments on that?
So yeah, that's a bit of a limitation of let's say blockchain networks, right? A typical use case that I come across in this case is, for example, storing medical data, where medical data might be imagery. You typically don't want to store the imagery in the blockchain network just simply because of the large amount of data that needs to move around. Yeah, and in that case, you need to provide a secondary data source where your records in your blockchain can map to that secondary data source. In some cases, that also then, you need to have the appropriate services. We have services like S3, which are globally accessible, that could allow you to store the different data sets and make a relationship between the two. But it is difficult. You really don't want to replicate very, very large data sets across the blockchain.
Hans replied again. He said, the speaker mentioned that as a user, you do not have row level access, which is part of ensuring immutability. If AWS has row level access itself, how can immutability be ensured? Or do you want to text
So the short answer is, AWS does not have access to customers' data. Services, we provide sort of encryption of this data at storage level. So we don't have access to row level data. We operate in general, AWS operates a process of least privilege. So you only absolutely have the rights as an employee, an engineer, to execute the work that you need to do, which typically doesn't involve looking at any customer data. So we don't have access to that data to change that data. It's encrypted.
I hope Hans is now satisfied with the answer.
If not, I'll type a message to Hans in a minute. That's fine.
Yeah.
Thank you very much for that, Julian. Before we hand over to Éva, I'll just share my screen with everybody. One of our partners, Cloudflight, they have a coding contest going on. And they would like for me to share this information with you. Just give me 1 second. All right, so Cloudflight has a coding contest, which will be happening on the 30th of October at 3 p.m. The contest itself would be for 4 hours. There are several levels with increased difficulty, and any coding language is possible. Their price is for the best one per location, and Amsterdam is included in that location. So you'd see a QR code in front of you. So if you'd like to scan that to get any more information, you can. All right. So what I'd like to do now is I'd like to hand it over to Éva.
Thanks a lot, and thanks for inviting me to talk about then the current trends of blockchain technology. Okay. As Jean introduced me at the very beginning of this talk or this meeting, I'm working at TU Delft, and I investigate scientific collaborations. And as you might seen these kind of graphs beforehand, based on scientific publications and how many authors are presented in scientific papers, the scientific collaborations are expanding, and then there are lots of articles which appearing that they have hundreds or even thousands of collaborators named. We deal with different kinds of scientific collaborations, and I won't go through all kinds of different parts of collaborations, but I wanted to mention the highest level, the transdisciplinary collaborations, because this is really important to us to investigate. This is the hardest type of joint work, where researchers and different kinds of professionals really integrate their knowledge, and not only their knowledge, but they also integrate conceptual frameworks, theories, models, and applications. So this is really hard to put together all kinds of knowledge and resources and also theories, and then work together to come up with a completely new solution from the different perspectives of the different disciplines. And this is, well, this can lead to a better innovation because you have a higher problem solving ability. You have more disciplines and more knowledge, more perspectives. But of course, it is really, really hard to work together because of team performance and group cohesion. And what are the frequent problems that we see in these kind of collaborations? Distribution of task, scheduling issues, managing projects, leaderships and organization issues, information flow between the partners, just to name a few. As you heard, the Dutch Blockchain Coalition is one of our case studies. This is a triple helix, a joint venture between industry, government, and knowledge institutions. They work together to solve some commonly formulated cases or work packages. As you might see, there are competing companies there. So there are different banks, IBN, ING, and also Rabobank are also involved in the collaboration in a joint work, which is really interesting because they are competition to each other, but they joined forces because they realized that there are some issues that they cannot solve alone. So as you see, the government is represented by different ministries and also other kinds of organizations as well. So we are part of then the Dutch Blockchain Coalition also as research partners. So we investigate the coalition itself as a collaboration. We give advice to them how they should operate better. From time to time, we do interviews with the different members and then give feedback to them. What is the status of the collaboration, how the teams are working. But I also lead a research group there. So I have some basic information how things are happening there. As I would expect, you have some background information on blockchain. But what the Blockchain Coalition finds really important are these 4 pillars: transparency, security, efficiency, and trust. And these are the pillars that are used as well in the Dutch Blockchain Coalition use cases. There are 5 of them. The first one is a self-sovereign identity, which is focusing on individuals to have control over how their personal data is used without the control of a third authority. Logistics is the second one, and with the use of blockchain, they try to make logistic chains more transparent, reliable, honest, and they expect that there will be fewer administration. And of course, in the case of energy supply chains, this could be really the best solution to apply. If you think about then how individual solar panels are calculated, their usage, and of course how much energy they put into the global system, this is really a tricky situation, and blockchain could solve that. The third use case is educational certificates and diplomas. There are some issues regarding then diplomas and let's say language certificates provided by other countries. By using blockchain, it could be verified and reliable and could be globally used if there would be a standardized system for that. The fourth use case is pension. They expect to have an efficient administration system, which lowers the cost of the administration, which is now paid by all employed people currently in the Netherlands. The fourth one is compliance by design. It is then a use case of the ministries or the government in the Netherlands, and they want to make the subsidy forms more transparent and the whole process of filling out or asking for subsidies more automated. So to make sure that only those people get the subsidies who are intended to get, and the process becomes much more easier and transparent and more easy to follow. If you want to get some more information about the Dutch Blockchain Coalition, well, how it's operating, then you can have a link. Click on the link here below and then see the vision document, Blockchain for Good. We work together with different scientists who are currently running research projects. And some of them are part of the Dutch Blockchain Coalition, some of them are completely unrelated, but this is a kind of snapshot of what kind of research projects are currently running where Dutch universities or hogescholen, applied universities are part of. And the main topics which are covered here are governance, logistics, trustworthiness. There are lots of projects running, not only NWO, the Dutch science funding organization projects, but also European Union funded consortiums are also part of this. There are also projects running under the term of privacy, security, and sustainability. And if you have a look, there are interesting projects as well. So the Open Education Infrastructure project is also focusing on putting the education infrastructure under not only the certificates, but the education system under blockchain. And there is an art project called the Blockchain 𝗕𝗵ci𝗰𝗶𝗰𝗵𝗶. So there are lots of other kinds of projects, not only about technology development and then making the blockchain as such more sufficient and more trustworthy, but then related to different kinds of applications. You heard one type of application beforehand by Julian. We could name thousands of different ones. But instead of doing that, I wanted to highlight one interesting phenomena, which is related not only to blockchain, but to all technologies. And this is the adoption of technologies. And I want to highlight this from the perspective of blockchain, and then think about all the aspects here from the blockchain perspective. So 𝗕𝗹𝗰𝗵𝗶𝗰𝗵𝗶, he's a philosopher, but also an engineer in Amsterdam. He had a function in the University of Eindhoven, but he has now the Next Nature Foundation in Amsterdam. And they work a lot about then how technologies could be more accepted, or how to talk with citizens, with the society about different technologies. They produce also an in vivo lab meat cookbook. This meat type is not available yet, but they came to conclusion that, okay, we have to start a discussion about that to make it more acceptable for people. So they asked designers to come up with a book, and then, yeah, just to really show that there are all different kinds of ways how you can imagine meat. So 𝗕𝗹𝗰𝗵𝗶𝗰𝗵𝗶 has created this pyramid of technology with the different stages how technologies are at our current lives. He says that at the first stage are the envisioned or imagined technologies. This is an old figure, so quantum computer is standing here in the envision, but I would say has grown into operational stage. So this is the stage, the envisioned, where an innovation is only at the dream stage. If you think about time travel or teleportation, these are the technologies that people talk about since a while, but they were not, and there are no working prototypes yet. So if it has shown to be working like quantum computer and lab-grown meat, then they are already at the operational level. And it is not widely applied there, but it has been proven that it can work. So it has been applied it has been shown in the lab to work. The next stage is applied when a technology was proven, so there is a proof of concept. It is, yeah, it can be applied, it can be done, it can be part of one tangible issue, and people are using. There are some early adopters, or there are already more people who are applying it. So it is accessible and also affordable. There are lots of, if you see this figure, there are lots of different technologies here. You also hear Zeppelin, and you also see kind of homing pigeons here. That means that there are some technologies which were accepted or vital, but as transformed here back or flown back here because they were competing on the level of usage. The next level is accepted when the higher society is using them. So they are part of our everyday life. You can see it, yeah, email. energy saving lamps, light bulbs, psychotherapy, lots of other technologies are listed here. The next stage is vital when we are used to the technology so that we are not even imagining our lives without that. I would say printing press, telephone, internet, smartphones has already reached this stage. So if you leave your phone home, you feel like, yeah, there is something missing. You have to have that. It's a weird feeling. But we cannot also imagine our lives without a sewage system. The next level, the sixth one, is invisible when we're not really realizing that this is a technology. So if you think about religion, writing, agriculture, and wheel, these are also technologies. Of course, they were invented a long time ago, but they are part of really our culture. They are authentic and intuitive. We don't even think that they are artificial technologies. And at the highest level of the pyramid, we find those kind of technologies which are naturalized. These are really part of human nature, said by 𝗕𝗹cie𝗰𝗵𝗶. So if you think about the clock, the controlled fire, and cooking, we cannot really imagine any human without that kind of technology operating. So if we have a look at blockchain, I would say it's already at the applied level. So there are lots of different applications of it. Of course, the technology is living. Bitcoin is widely accepted. So it is between applied and accepted, I would say. It is not by the majority of societies using it. It's not made into the vital step for sure. Of course, one could just philosophate about the issue that we would like to get that into the higher levels, right? The more advanced the technology, the more accepted and part of our everyday life, is it better for everyone? But we have to stop here for a while and then think about it, because if it becomes vital or even higher, then we cannot really remove so easily that technology from our part or our life. So it has to be really authentic, it has to be ethical, it has to be politically correct. So we have to ask questions which are related to politics or societal issues and also ethics. And in the term of blockchain, we have to ask questions that what about those people who are not really educated in using computer sciences and so? Does anyone would be able to use blockchain if we would say that the compliance by design project would be accepted? Do a citizen needs to understand blockchain to be able to use it? A lot of people say that, okay, the HTML code under the internet sites are also not understood by most of the people, but they are widely accepted and used. But there are issues with blockchain thanks to Bitcoin, which raises questions of trust from the citizens. So we have to start a discussion which are not technological, not technology or technique based, but our society or politics and ethics based. So this is what we do at the Communication Design for Innovation. We bring together the individuals, the organizations where they work at. We try to try to understand how they work together based on the technology that they are trying to develop, and also involve society and ask the different kinds of not easy questions and put them into a network which is called adaptive innovation. It needs empathy and observation, how people actually live their life, what kind of problems do they observe. And yeah, luckily it is happening then in the blockchain coalition as well. So if you think about the compliance by design, they realize that people have problems by filling in forms which were designed before, and there isn't a need for change. So they incorporate then the feedback from people into the design process. Well, we need to come up to the prototyping and intervention phase as well, when we try out blockchain and we investigate how people experience the different usage, how they respond to using blockchain, what kind of dilemmas and feelings do they have as well in the whole thing. Just to give you an example how we do these kind of things, this is one of the thesis projects of a master's student. He was investigating how different kinds of companies make decisions about using blockchain, and he figured out that there are some visionary people who are completely into the blockchain field, and they see the future X stated here, that this is how we are going to use blockchain. But for most of the decision makers and also people who are deciding on the budget of the company, they don't see, they cannot really imagine this. And this is the way how he came up with a solution, just to come up with a disruptive future frame and to investigate then how can you make it really tangible for people, the future. How can we bring that into a smaller, imaginable and trustworthy future? So he came up with different kinds of theories and also different kinds of design techniques, and he designed interventions. So this is typically what we do. We design intervention tools, which could be canvases or different games that start a discussion between different kinds of stakeholders, and they started a discussion about the different issues of blockchain. What kind of issues do we need from blockchain? Trustworthiness in the company? Do we need security? And so on. So these are the different steps. He tried out these interventions and he made them better and better. So the final tool became his tool to create an intervention in companies which try to use blockchain, but really could not translate then the future, imagined future, to the decision makers. So this was my part. Are there questions?
Yes. All right. We've got 2 questions. First one is from Jasper Kool, who wonders, blockchain also consumes a lot of energy. What's your opinion about that? If it's overall a useful added value?
There are lots of research projects focusing on then the sustainability of the technology in that way as well, that it will not use that much of energy. How could that be solved? So I think, yeah, this is an issue, and if we put more and more applications to blockchain, then it will cost us a lot more energy. It has to be solved. It's a crucial problem.
Okay, and another one is from Mersat. He wonders, how is blockchain solving the issue of trust within the scientific community when it comes to sharing and collaborating? Can you provide more details on how this works? How does this increase trust among scientists to share data and work with each other?
That's a very interesting question, because this is one of the typical examples that I like to talk about, that in the blockchain field, especially engineers and computer scientists talk about trust in a completely different way as we do in the scientific community, in the other types of engineers. So trust is then, in a blockchain terms, means something completely different than trusting each other and sharing information. It's a distributed trust, and but there is a project which tries to solve all kinds of fundamental problems with the scientific life cycle and tries to use blockchain or the fundamentals of blockchain there. It's called the Blockchain for Science. It's a huge umbrella term for different projects. And there are lots of issues there under the problem of trust and sharing information. The first one is ownership. And one potential using blockchain in that perspective would be timestamping ideas, or just to publish not full papers, academic publications, but ideas as well. So if you could use blockchain and timestamp an idea or a hypothesis, you could be then referred to as the original author of the idea, and then some would go into the lab and test it out, but also refer to you as an idea maker. So in that way, trust would be an idea sharing, and ideation would be an easier way by using blockchain.
Mersat again asked, I assume an ID is not patentable.
Probably it does not work to be patented. It has huge costs. If you patent an idea, you have of course, different options. To patent it nationwide or region-wide, like in Europe, or globally. It have different costs and different time frames. And well, if you don't know what it will deliver at the end, probably it does not worth it to patent an idea.
All right, and see, we still got some time left. We got till 1 o'clock, right? Exactly. Or is there something that needs to be said before that?
Yeah, actually, there are a couple of announcements that I need to make. But
Okay.
if there's one more question that can be answered, if not, then I would proceed.
Yeah, I was kind of wondering why at the start you said that there are a lot of banks actually who were kind of involved with the with this in general, and I was wondering why is it that specifically banks are so interested in this, because I noticed there weren't necessarily a lot of other companies from a specific sector. The banks, I guess, are very
yeah, my honest opinion in that is that they have to come up with a plan B if Bitcoin and their blockchain bodies will become really widely accepted. Then the banking system would be completely disrupted. So they try to come up with a solution how to survive, and they also want to include then the authority of the banks in the peer-to-peer system, which is also a kind of weird philosophical issue. If you think about then the whole idea behind Bitcoin, that you don't need the banks, they would say that, okay, we can take Bitcoin into our bank system. We can incorporate that. So then twisting the whole idea.
That's all right, thank you. I think that finishes the Q&A then.
Thank you.
All right, thank you very much for that, Eva. So before I conclude, we've just had someone from the AI Startup Lab, Vladimir, that would like to share a thing or two.
Hello, so good afternoon once again. My name is Vladimir 𝗕𝗹ecie, and I'm here on behalf of AI Startup Lab, which is part of ACE. ACE is an incubator from Amsterdam's academic institutions. So UvA, VU, and 𝗕𝗹cije, and the two medical centers. But our part, the AI Startup Lab, focuses on AI concepts only within ACE. So ACE offers an incubation program, and we are sort of a pre-accelerator for all sorts of ideas, which may come from you students or from the corporates. So if you are a student that has a dream to do something more in the AI field, whether you are an AI student and you would like to take this idea further, or you would like to work on a real life challenge or a use case coming from the corporate world, please come talk to us. We want to provide students with a sort of a sandbox, with a playground and an opportunity to validate startup ideas, wherever they might come from, in a real world setting, and expose students to the most relevant aspects of entrepreneurship in a very sort of in a pressure cooker setting, so in a short period of time. We have mentors that are both experienced entrepreneurs and AI experts. We have the corporate sponsors, and we have collaboration with business and entrepreneurship students to make teams more multidisciplinary. And we have already had some startups that have gone through this journey, and we have successful created some startups out of it that you can talk to. One of them is pictured here. Those were the AI students that created a company called Integral AI and are now working with the corporate sponsor, which in that case was ABN AMRO. So if this sounds interesting, please come and talk to us. You can apply via the button in the slides, or write to us at hello@aistartuplab.nl. Thank you very much, and I wish you all a good day.
Right. Thank you very much for that, Vladimir. To just kind of like add on top of that, I think Vladimir already pointed towards it, but the ACE incubation program is also a program that is running. So if you are interested in starting a tech or science-based company, the ACE incubation program is someone that you can go to. The program is for 9 weeks. It lasts from November 9th to January 18th. And the deadline to apply is the 26th of October. So if you'd like to know a lot more about that, or if you want to know more about that, you can visit the link. Now that we are approaching this is the end of the webinar, I want to give a special thank you to Éva and Julian for your amazing presentations. They were very enlightening. Thank you very much for that. Thank you very much, Kuntu, for leading on the Q&A sessions. We'll be having another webinar in 2 weeks' time on the 28th of October. Where we'll be partnering with the Study Association VIA, and that webinar will be on ML, so machine learning and symbolics. So you're all invited to join that. So yeah, thank you very much.